For the next segment, we are not going to flatten the dictionary. Let's print one sample output, say prediction list of 1. Okay. If we flatten the dictionary, flatten the prediction list, what happens is when there are multiple menu items, here you can see that it gets flattened out. And if we try to find out the precision and recall for every single key, then we'll end up having multiple keys where you have menu 0 of name, the precision for the first line item, the precision for second line item, so on and so forth. Instead, we would like to stick with the same level, like what is the precision of key name under menu, so that it doesn't matter whether it has 2 item or 3 item in items. So we are going to use a utility method which is called extract values. The purpose of this method is when you give a sample dictionary input, the level and what are the key that we want to find, it basically looks into the existing dictionary and returns the key value for us. So for example, when I say extract values of, in this case, my data is prediction list of 0. Okay. And I want to look into the menu level and I want to extract the name of the menu, then which is basically the name key, right? So if we print prediction list of 0, here we are basically extracting this string, and if we pass this to this method, then it's going to give us the prediction of. Okay, so this utility is more helpful because we want to in case of say prediction of 1 where we have multiple line items, it is much helpful for us to gather all the names together and perform a calculation, like to identify how many false positives or how many false negatives we have. As the next step, let's go ahead and find out the list of keys for which we are going to calculate the precision and recall. So keys to evaluate is going to be a list, and say we want to find the keys. If you remember, we defined a schema dictionary. Let's print that. Okay, so we are going to be interested in menu, say subtotal. So these are the high level keys, and the third key is total. Right now, for k in keys, for each key, let's go ahead and get the dictionary from the schema dictionary, right? Schema date of say k, right? Now say this D is going to be the nested dictionary, and I just want the key names from this. To do that, I'm going to iterate for k1 and d dot keys, and I'm going to do keys to evaluate dot append. Let's append this keys together with dot separated. Okay, and the top level key will be k and the bottom level key will be k1, and hence we're going to get the result as keys to evaluate. It's going to be like this, where menu.name, menu.number, menu.number, and unit price, and so on. Now here we have 3 segments. Of course, there is a nested segment which is called sub. Right? So let's include that in the keys list. However, we cannot do d equal to schematic of k because the sub menu is nested. So let's add a condition here. If k equals sub, then our dictionary is going to be schema date of menu of k, or else the dictionary is always going to be schema date of k. Right now, let's run this. Here we can see. So now we have, after the menu, we will have the sub menu, where we'll have sub menu name, the sub menu unit price, count, and price, and etc. Right. So these are the keys that we are interested in, and for every single key we are going to derive the precision recall. Okay, now let's iterate through the ground truth and prediction in zip of, say, ground truth list and the prediction list. Okay, for every single ground truth and prediction, we have to evaluate the precision recall for all these keys. So for key in keys to evaluate, let's paste. For every single key in keys to evaluate, we have to derive the key from ground truth and prediction. To do that, GT values equals this, data will be GT, level will be, okay, now we need level and the key. If you remember, the value key is nothing but the level and the sub level. So level comma sub level equals key dot split of top. Right, now we get the level and sub level. So for example, menu and the name, right? And here we pass the level, and I guess it's a key. Here we pass the sub level. And similarly for spread values, we are going to say extract values, copy paste this one, but in this case the input is going to be red, right? Let's print the GT values and the spread values just to make sure that things are working correctly, and let's add a break statement here. Right, okay, now cool. Here we can see the first, okay, let's print the key as well, just for the understanding purpose, and remove this break, so that for the first invoice we're going to print the key, we're going to get the value, the ground truth values and the prediction values, right? So here we can see this is the key, this is the ground truth, and this is the prediction value, and it also has the if the key does not exist, then it gives you the empty list. If there might be a case where we are handling with multiple data types, so it's good to convert everything to string just for the sake of comparison. So GT values, say str of x for x in GT values, again same spread values equals str of x for x in spread values. Right, now we have list of strings which we can compare. Okay, now we have to compute the precision recall, I mean F1 score for the key, right? For each key we are going to compute the these three metrics. Let's create a method called compute metrics, and it takes the ground truth list and the prediction list as input. Now we can divide this into three segments. First, we can calculate the exact matches, which is the true positives. The second one is the false positives, and third one is the false negatives. Okay. Now, in this example, we have only one menu line item, and hence it looks like this. But there are cases where we'll have multiple line items. For example, if you remember the second example, right? Let's just, instead of break, let's do if I equals 3, and then break, so that we have two different examples. Let's print this. Okay, here we go. Here we can see, okay, this is the second example. First one is the ground truth and second one is the prediction. Here we can see that when we try to extract menu.name, it basically gives us a list of all the elements tagged to this menu name. For every single key, we are going to get the list of elements which are present in the ground truth and which are present in the prediction. Right, so basically we want to compare how many of them are matching between ground truth and predictions. For that, we are going to use the counter. So for collections, import counter, right? Now to find the exact matches, we are going to say first take GT counter equals counter equals counter of GT values, and pred counter is equal to be counter of pred values. Okay, let's say let's stick to break for now, and let's just call this method compute matrix of GT values and pred values. Okay, now we have this values present. Let's just print the counters now. Pred counter, right? Now let's run this here. Now we can see that every single key is represented as a dictionary with the corresponding count, right? So to identify the number of true positives, let's say TP equals 0. Let's to count how many true positives we have, and then let's say we will have matched prediction. This is going to be, let's have it as a set. Okay, now for key in GT counter, right, for every key in GT counter, if the key exists, if the key is available in the prediction counter, right? So for example, on the first iteration is going to check whether this particular key is available in the prediction counter, because we are talking about true positives where we are going to find the exact match, right? So our true positive is going to be do a min between the GT counter value and the prediction counter value. In this case, we can do is say minimum of GT counter of key, and prediction counter of key. Imagine a case where we have say 3 ground truth elements and 2 prediction elements. Okay, there are cases where 3 ground truth elements and 3 prediction elements, and let's say 2 ground truth elements and 3 prediction elements, right? In the exact matches, we want to know whether the 2 values which are there in the prediction are matching with 3, right? So when we try to compute a min, imagine a case where 3 ground truth elements and 2 predictions, and these 2 predictions are matching, then it's going to be min of this. If say 3 both are having 3 predictions, then eventually it's going to be min is going to be 3. And if the ground truth has only 2 and the prediction has 3, even in that case, if 2 values are matching, we are just going to increment the true positives. Append this particular value, add this particular value into the set which we have created. The next one is the false positive. So false positive cases are like extra predictions which are not available in the ground truth, right? So let's say FP equals 0. So we are going to increment FP only when, say, for val in prediction counter, for every val in prediction counter, if this particular value is not in the ground truth counter, then that means it's an extra prediction. In that case, then we are going to say prediction counter has such values. Say for example, it contains 2 values which were present in the prediction, however it was not there in the ground truth. Then we are going to just do the sum of such elements which are going to be our false positives. And similarly, false negatives are the ones, basically it's the missing predictions in ground truth, right? So this is the reverse of false positive. So false negative is going to be sum of GT counter of val for val in GT counter if val not in prediction counter, right? If the value is available in ground truth but not available in the prediction, then we are going to identify the number of values and then do a sum, and it's going to give us the false negative, right? Now we have the true positives, false positives, and false negatives. Let's just return it as a dictionary. True positives is going to be TP, false positives FP, and false negatives is going to be FN. Right? So when we invoke this compute matrix method for each and every key, we are going to get the true positives, false positives, and false negatives. Remember, this compute matrix is getting invoked in the second for loop for every single key that we want to evaluate, and hence the method which returns the list of three values, which is a dictionary. We need to store it somewhere, so let's create a matrix dictionary for every single key, for key in keys to evaluate. Right? Let's create a dictionary for this key which contains the true positives, false positives, and false negatives initiated to 0. Right? So now we have initialized the values to 0, and whenever we invoke this method, let's say for this particular instance, it's instance matrix, what we are going to do is split this instance matrix once. Right? Command this split. Now for every single key, we have this matrix derived, where we find true positives in case there is a match, false positives in case there was any extra value, and of course the false negatives if there is a case where it was present in the ground truth and not in the prediction. Right? Now the next step is to append this values to the matrix dictionary for every single invoice. Let's update the dictionary matrix of key. So the matrix of key will have the dictionary. So for true positives, let's go ahead and update the true positives which we received from instance matrix, and similarly let's do the same thing for false positives and false negatives. Right? So for every key, the value gets incremented if the true positives or other keys are set. Right? One other important information that we can gather here is the total ground truth. So because we know how many keys exist in the ground truth, and we know how many true positives exist, it might be easy for us to identify the accuracy as well. So to do that, we can add one more metric, say matrix of key of total ground truth is going to be the number of keys which are there in the ground truth, which is nothing but length of ground truth values. Right? So yeah, let's go ahead and remove this break statement and comment this out. Yeah, let's run this. Now it has run for all 100 invoices, and here is the overall metrics. Now we have whatever the we have all the relevant information with us. So let's do the final step of calculating precision recall and the FX score. Let's say final matrix equals this. So for key comma value in say matrix dot items, right? Now this is going to be the key and this is going to be the value. We need to get the true positive, false positive, and false negative values from this. So value of QP, value of FP, and value of FN. Okay. Let's print TP, FP, FN and do a break. Okay, we got it. Now the next step is to calculate precision. So precision for us is going to be true positive by true positive plus false positive. However, we need to make sure that the denominator is not 0. If true positive plus false positive is greater than 0, else we are going to set it to 0. And again, the next thing is the recall. For recall, it's going to be true positive by true positive plus false negative. If true positive plus false negative is greater than 0, else set to 0. And we can even compute accuracy here because we have two important information, which is nothing but the true positives. And true positives is the number of matching items, total, say, ground truth. Let's call total GT and gather that as well. Now, what we can do is true positive by, say, total GT, right? Again, we need to make sure that if total GT is greater than 0, else 0, right? Now what we can do is, this is for every single key, final matrix dot append, right? Let's do this, where we'll have precision, precision, recall, recall, F1 score, F1 score, and accuracy, accuracy. Of course, we need to know for which key it is, so let's have the key as well here, right? Now, this is going to be list of dictionaries. Let's run this. Okay, we got an error. Okay, final matrix is going to be the list. Okay, F1 underscore score. Okay, so final matrix df equals pd.data frame final matrix, and then let's print this data frame. Okay, here we go. We have the F1 score, precision, recall, and accuracy, and we can see many of them doesn't have this F1 score, right? I guess we don't have enough information for these. So what we can do is we can exclude such keys. Let's do final matrix df of final matrix df dot F1 score greater than 0, or maybe we can add the total ground truth here, total GT, right? So how many GT elements were there, and then comma, okay, and then we can just do total GT greater than 0. If the ground truth exists, then let's go ahead and analyze the results. Okay, the value for F1 score looks really odd. That's because we made an error here. The formula for F1 score is 2 into precision into recall by precision plus recall, right? Only if precision plus recall is greater than 0, or else set to 0. Let's run it again. With this, okay, now we have the F1 score. From this result, it is very evident that model is performing around 60 to 70% of accuracy, where the values between the ground truth and the predictions are matching. However, if we look at the precision recall in the F1 score, it is very clear that model is adding either a lot of false positives or missing out a couple of false negative values, and due to which we have a toll on F1 score. As the next step, if you remember, we had the data set where we had the training, validation, and the test set, and we have used only the test set, which is 100 invoices for this particular evaluation. Now that we have the baseline result, let's go ahead and utilize the training samples and perform a fine tuning on the vision language model and see how well we can improve the accuracy of this.